Hello everyone, myself lecturer Aditi Anil Kushare, Master of Pharmacy in Quality Assurance Techniques. Today we are going to discuss about the experiments from pharmaceutics too. So first of all we are going to discuss about the semi-solid dosage forms. In that the semi-solid dosage forms are mainly meant for external application, for an example ointment, creams, jellies, pastes, poultices, etc. In that we will discuss about the ointments. So ointments, these are the semi-solid preparations meant for external application to the skin or mucous membrane. They usually contain a medicament or medicaments dissolved, suspended or emulsified in an ointment base. Ointment bases, it is that substance or the part of an ointment which serves as a carrier or vehicle for the medicament. While selecting a suitable ointment base, the factors such as the action desired, nature of the medicament to be incorporated, and the stability of ointment are to be considered. So we will discuss about the classification of ointment in detail. There are total two classes: therapeutic properties based on penetration, and second class which is based on therapeutic uses. So therapeutic properties based on penetration get classified into three types, that is epidermic ointments, endodermic ointments, didermic ointments. According to the layer of skin, all these three types of ointments are get classified. Therapeutic uses, in that first antibiotic ointments, antifungal ointments, anti-inflammatory ointments, antipruritic ointments, astringent ointments, anti-eczematous ointments, keratolytic ointment, counter irritant ointments, for dandruff treatments, for psoriasis, then parasiticide ointments and protectant ointments. Next we will discuss about the classification of ointment bases. There are total four main classes, in that oleaginous base, then absorption base, emulsion base and water soluble base. In oleaginous base, first type is a petrolatum, that is a soft paraffin which is having melting point of 38 degrees Celsius to 56 degrees Celsius. Second one hard paraffin, and third liquid paraffin. Absorption bases again get classified into two types, that is non-emulsified bases, and second one water in oil emulsion, that is W/O emulsion, in which water is the internal phase while oil acts as the external phase. In non-emulsified bases, it is again of the four types, that is for an example wool fat, wool alcohol, hydrous wool fat, beeswax. Then emulsion bases is of two types. O/W means oil in water emulsion, in which oil acts as the internal phase while water acts as the external phase. And second one, that is W/O emulsion, in which water acts as the internal phase while oil acts as a external phase. Water soluble bases, carbowaxes. Then factors which govern the selection of an ideal base for ointments are, there are total two factors, that are dermatological factors and pharmaceutical factors. In dermatological factor there are again they are of seven types, that is absorption and penetration, first factor. Second one, that is effect on skin function, then miscibility with skin secretions and serum, then compatibility with the skin secretions, freedom from irritant effect, emollient properties, ease of application and removal. Second, that is pharmaceutical factor, in that it is having the 4 points, that are stability, solvent properties, emulsifying properties and consistency. Then preparation of ointment, in that there are 4 methods, that is trituration method, fusion method, chemical reaction method, and fourth one emulsification method. Let's discuss about the additives used in ointment, that are preservatives, methyl paraben or propyl paraben, humectants, that are glycerin, propylene glycol or sorbitol, antioxidants which are used to prevent the oxidative decomposition, chelating agent is used to prevent the catalyzing oxidative degradation of the trace elements. So we know the example of antioxidants, that are BHA, butylated hydroxyanisole or butylated hydroxytoluene BHT. Then in case of chelating agent, that is the best example is EDTA, means ethylene diamine tetraacetic acid, which is the best example of chelating agent, that is also known as the sequestering agent. Recommended containers, the semi-solid preparations are dispensed in the glass or the plastic jars having screw caps with the impermeable liner. They should be stored in the well-closed container so as to prevent the loss of volatile constituents. They can also be supplied in the plastic or the metallic collapsible tubes. Then special labeling instructions in that store in a cool place for ointment containing low melting point ingredients, and second one that is for external use only. In next session we will see in detail about the experiments. Experiment number 53. Title of this experiment is to prepare and submit the emulsifying wax IP, that is according to Indian Pharmacopoeia, 10 gram. Preposition 1. Sodium lauryl sulfate is a mixture of sodium salt of sulfated normal primary alcohol. It is an anionic emulsifying agent. It is used in the preparation of emulsifying agent for producing OBW creams, means oil in water, in which oil acts as an internal phase while water acts as an external phase. Sodium lauryl sulfate reduces the surface tension and it can be used as a wetting agent and detergent. Learning objectives are to understand the type of ointment and to understand the method of preparation of ointment. Apparatus required are beaker, measuring cylinder, white tile, ointment spatula. Factor calculated as ointment quantity required upon quantity given, that is equal to 10 upon 1040 is equal to 0.009. So we have, this is a prescription which is denoted by the RX cytosterol alcohol 900 gram, sodium lauryl sulfate 100 gram and purified water 40 ml. Let's discuss in detail about the formula table. We have, this is first of all type, that is quantity given, type means the role, category or use of ingredient. Translation means the name of ingredient, as the quantities are directly given in the metric system. No any Latin terminology, so no, the quantities are not given in the imperial system. The quantities given in the metric system for 1040 gram and quantity taken in metric system to prepare up to 10 gram. So first of all, cytosterol alcohol used as emulsifier, quantity given 900 gram. With the help of factor we can calculate the quantity taken, that is 8.1 gram. Sodium lauryl sulfate SLS, that is used as a surfactant. Quantity given in the metric system is 100 gram and taken quantity should be 0.9 gram. Purified water used as a vehicle, quantity given in the metric system is 40 ml and quantity taken in metric system, that is quantity sufficient to prepare up to 10 ml. Direction to be used as directed by physician. So we have cytosterol alcohol which is taken onto this previously weighed. This is a sodium lauryl sulfate SLS which is previously weighed, and this is a purified water. So first of all, I am going to heat to melt this cytosterol alcohol. I am taking it into this beaker and then we will proceed for heating. So now we will move towards heating. We have to heat this cytosterol alcohol. We have to heat it up to 90 degrees Celsius. So after some time we will check the temperature of this solution. Now I heated it till 90 degrees Celsius. As our product become liquid, so now I am going to add the sodium lauryl sulfate SLS into it. Now I added the sodium lauryl sulfate SLS into this liquid cytosterol alcohol. After that I am going to add the purified water into it. So now this become the solution of cytosterol alcohol, then sodium lauryl sulfate and purified water. So after proper mixing and heating of it, now we will cool it and then proceed for next part. So now after melting it, this solution becomes cool. So now we will move for the volume makeup. So now I make up the volume up to 10 ml. Now I am going to transfer it into this container and then we will next proceed for next labeling part. Now we will move further toward the labeling part. So, emulsifying wax IP 10 gram for ABC, name of patient, register number XYZ, number given in the register, dispensed by